Okay, how's the audio now? I had to disturb my live streaming setup. I'll give you a preview of what that looks like. Um, Hello again. Welcome to episode 15. Let me know if the audio is coming through now. Um, cool. So we'll get started with the sort of the Q&A answering section of this, or I'll give you a choice. We can either revisit this guy, or we can jump to Q&A. Which one would you prefer first? We're going to keep this sort of informal because I'm also in the middle of eating lunch. So, no, it's not you. I goofed. So let me show you the janky audio setup, the whole computer setup I have right now. Let's transition to. So this is my current work area. I'm streaming here. I've got my laptop covering OBS, so that's my audio panel. So I was not able to see which input I was selecting. I had to bring this guy up because today we're going to cover some of a really common question. It's what's the difference between the BitSetter and the BitZero? Don't mind my lunch. So we'll go over that. And then if you guys have any other questions, let me know. Do we have a consensus on, do we want to do the little project first or the Q&A section? I'm leaning towards the questions because that's easier, because I still have to do the setup. We'll go through start to finish. Let me transition the camera. Hold on. Trying to set a top-down view of the Nomad. So I still have the same stock from last time. You can see the cutout from where this used to be. So I'll go through the process, loading a tool, using basic adhesive work holding here, and then go through some cuts, and then also iterate on this, because based on the measurements I took last time, there's a little bit of slop in here that I definitely want to address. And then there's also a little wiggle room here. So I'll talk through some of the improvements that I did after making this the first time. Also, if you're curious, last time I was stymied by this machine. Turns out there is a door interlock here. So it's a safety feature that we had on earlier machines, and I think the European machines and education machines. And I forgot that with the door open, you really can't jog the machine or do anything at all. So let's see. Yes, the Shabogo can totally machine Nagiri. I can't guarantee it'll come out well, though. I'm seeing my choice and small project. Okay, so we shall do the project. So let me reposition my camera, and we will cut back shortly. So shuffle over, move my big camera. I gotta undo some twist ties here. The cable management here is not great, and HD wireless transmission is not exactly up to par yet, so I think I'm not gonna break anything here. All right, this is going to be physically awkward for me because I'm working around a tripod. Let's transition to the main camera view. Cool. All right. So we'll start by trying to machine this. Actually, let's go over the changes that I need to make here. Let's go back to the desktop. Let's see, turn off. There. Okay, let's do this. So based on what I observed last time, there was a little too much slop in some of these features. So I actually want to make these slots just a tiny bit narrower. So I'm going to resize these and just change the width. Let's go 25.75. No, that's not what I want to do. So everything here is grouped. So when I select just the SD card slots, it also changes the USB-C slots. That is definitely not desirable. So let me ungroup these and then select just these guys. So I want to make these a little narrower, so I'll resize them. Width, let's drop it by 1/4 millimeter. It's not a ton, but should be enough to make this a little less sloppy. I think I just changed my height too. I don't think it'll matter though. And let's recreate some toolpaths. So for my small features, I'm using a 1/16 inch end mill. Let me check that. And then, okay, so that's a 1/16 inch end mill, making the SD card slot and the USB-C cutouts. And then I'm going to switch to a, for my SSD holder, I'm going to use an 1/8 inch down cutting end mill. And then for the cutout, it'll also be an 1/8 inch end mill. It's missing the contour, so I'll reselect that. Cut on the outside, go to stock bottom, check. So I've got two toolpaths for an 1/8 inch end mill, one toolpath for a 1/16 inch end mill. And I can export both of these together. There's also one more little nuance of the part that I realized. So let me bring in. So this is supposed to be 1/2 inch plywood. Realistically, it's about a 32nd of an inch less than that. So when I programmed this stock in as 1/2 inch thick, and I told the end mill to plunge as deep as the 1/16 inch cutter could go, which is a 1/4 inch, it actually effectively only plunged to maybe 3/16, a little more. So the dongles, I don't know how well you can see that, they don't go as deep as they could, and so there's plenty of wiggle room here. So I'm actually going to machine or program in these pockets to go a little deeper than a 1/4 inch. So I'm going to go back into my small features toolpath. I'm going to change the max depth from a 1/4 inch to let's go another 1/2 millimeter. And then I'm going to export all of these toolpaths together, so they're all enabled. Save G-code, go to desktop, dongle.nc, and then, all right, now we can cut to the main camera. Clear the drawer, and switch you guys over. Okay. Let me brighten this up a little if I can. It's better. Yeah, close enough. Color temperature's a little off, but we'll live with that. All right, so we're starting like this way. With my, actually it's not my favorite, that's a lie, 1/2 inch plywood. Let me get some tape. So I'm using the double-sided tape we typically carry. And I already got the 112 1/16 inch end mill loaded up. So I know what the footprint of my part's going to be. I like to just cut in the lower left corner just to make this sort of symmetrical and just use up this stock. Let me make sure that this piece will fit. So yes, plenty of room. Now I want to cut on this side, so I got to remember that I got to put tape on this side. How much double-sided tape you use is kind of subjective, but over time, after a couple mistakes, you'll figure out how much you actually need. So for something small and simple like this, I think about 3 square inches is roughly enough. Um, if you want to be smart about this, you should also put a piece of tape somewhere out here, just because once your part gets liberated from your stock, the stock is also liable to go flying off somewhere. So it's always good practice to put some tape on both sides. And let's see how long it takes me to get the backing off this tape. It's typically not that bad. Let me check the focus here in just a tiny bit. It's not that bad unless you've recently cut your fingernails, but some tapes also have thicker backing, which I really like. 3M, 410M is really nice, I like, because it has a green backing, so there's no way you would accidentally leave backing on there, because the color similarities can sometimes fool you, and you might forget to take a piece off, and once you start cutting through things, you're like, why is this whole half wobbly? And it's because you probably forgot to peel the backing off the tape. So, I think this piece is a little warped. I can see in the back corner here, it's not going all the way flat, but this side is secure, which is all that matters. So I need a trash can. It's my trash can. So I need to get access to my mouse, which is like over here, super awkward. And I'm going to just check my tool length, because I haven't run this machine in a while. I should relocate this so that you guys can see a little better. Hold on, let me loosen up the USB cable so I can bring you over. All right, this is actually completely almost impossible for me to work, but I'll try not to stand directly in front of the light. I need to jog this over here to figure out my zero. I think I'm zeroing off the bottom of the stock. Let me check Carbide Create one more time. So let's see. Checking the, going to setup, stock thickness, half an inch, zeroing off the bottom, so that is correct. I don't know how well you can read that, but let's go back here and let's zoom out a little bit. And I'm going to start jogging over. Actually zoom out a little more and give you a view of everything I'm doing. So I'm going to rapid position to probably this corner. So southwest. And then I don't trust my Z offset since I haven't run this machine in a while. So I'm going to switch to fast jogging and use the comma key to bring us down. 3 to switch to 1 millimeter increments. And I'm going to find my Z first. So switch to 2 for 1/4 millimeter increments. I'm really just eyeballing this. I need to get it within 0.008 inches of the bottom, because most double-sided tape is about double the thickness of a sheet of paper. I overshot a little bit. So now that's my reference level. So that is Z0. There we go. And I'm going to zero out my Z. And then I'm going to start jogging up a little bit so I can get over my workpiece. And we're going to go right about there for my X and Y zero. Because this piece has a radius here, the corner of the bounding box is actually a little off where it's not going to be over your stock. So even though I'm sort of over this radius, I know most of the piece is going to be inside the stock that way. So I'll just set my X and Y zero. Zero those out, and then let's load the toolpath. So load file, Go to desktop dongle.nc, hit open, and I think we're ready to start the job. Let me push this overhead camera a little back so it doesn't fall into the workpiece and ruin everything. Start job. So whenever you first start anything on the Nomad, it just does a touch off for safety. Then it'll prompt you to load the correct tool, in this case the 112. So please insert tool number 112, 16th inch end mill, resume. I will, we don't need safety here. That's a lie. We do need safety. I am wearing glasses. I'm also going to just preemptively drop the volume. So this should take a couple minutes. And during that time, I will also try and maybe eat some food. Quick intermission. I'm just going to jump in here and bump up the feed rate by probably 40%, just because it sounds like it's going pretty well, so that should help it complete faster. The decision to increase your feed rate is totally subjective, but if it sounds like your CNC is not having any issues whatsoever, like feel free to just crank it up. The worst you're going to do is break an end mill, but in a really light plywood like this, you can push it pretty hard. I heard someone say stock movement. Is that confirmed? Can anyone corroborate that? Um, for those of you that are asking, or that one person, this is a brushless DC motor. It's in a square NEMA form factor. It's not actually a stepper motor. It is a fully brushless spindle. Common misconception just because it's square, but you can actually get motors in that form factor. Tape not holding. Oh yeah, that is super duper weak. Well, this will provide a fun exercise to perhaps correct these issues. So let's figure this out and see what we can do to solve this issue. All right, this is going to be a little more interesting than I expected. I'm going to cancel the execution of the current program, and then let's see how we can fix this. My mic's getting dragged down. There's just a lot of stuff going on here. Where's my pen? Actually, let me grab the vacuum and clean this up, and we'll sort this out. All right, let me switch to the desktop cam, and let me also change up my camera options. All right, I think that's a better view. Hold on, I need to see if I can reach the vacuum without yanking my lav mic off my shirt. All right, so let's talk about how we can fix this issue since apparently things were moving. I'm going to take a look at the slot. If an SD card will still fit in there, I think we don't need to redo that toolpath. So let's do a check. Yeah, so SD card is actually still good on all the slots. So I'm not actually too concerned about that. I just want to make sure that if I throw some more tape down on here, because the 1/8" toolpath is going to be significantly more violent, and that's what might dislodge this piece. So I definitely have to put more tape on here. So what I'm going to do, just to make sure I don't lose my 0 when I reposition this, is I'm just going to mark down where my stock previously was. You could also tape down some blocks or clamps here as a fixed reference, so that when you pry your workpiece off, you can just butt it up against there again. I gotta figure out where tape's still clean. I'm just trying to figure out, is it because the stock is saddle shaped, or where that movement's coming from? I think it's the stock not being perfectly flat, and so when I press down on here, it levers this side up. So I might just leave all my tape, just a big chunk of it, in this quadrant. Could also be that the surface is dusty, but the tape is pulling up clean, so I don't think that's the case. All right, so let's try this again. Let me just go through this again and try and figure out where the best spot for tape is. I think anything in here, just looking for any movement, it's pretty good. So there's a little bit of sawdust in here that I'm trying to get out. Let's try this again, and let's not hold back on the tape. So that thing I said earlier about knowing how much tape to use also depends on how flat your stock is. So I'm going to do 3 lines of tape. Just load it up. The 1/8" end mill will probably touch this tape and get a little adhesive on the cutter, but a little Goo Gone, Goof Off, or any sort of solvent, even isopropyl alcohol, will sort of help lift the adhesive off the cutter. So it's not too big an issue. But if you're doing a contour cut, you touch the tape, and then you do another pocket or you cut somewhere else, then you can transfer and cause sawdust to stick on the outside walls of what you just cut out. So, let's stick this down. Let's see how it holds, and then let's do the 1/8" cut. I'm going to have to re-export the toolpath for the 1/8" end mill separately, since I exported a single toolpath this time. But it'll be a really quick fix. So make sure we get a clean surface. I need a better place to put trash. No dust. And let's try and line this up as best we can. Honestly, it just needs to be good enough, because the cuts that the 1/8" end mill will make are completely independent of the SSD slot here and the final cutout. That seems more solid. I don't really want to push it, but fingers crossed, I think it'll hold. So let's swap that out to an 1/8" end mill, and we'll make the new toolpath. I should probably have switched to the full camera feed, so let's do that. All right, where's the end mill I want? This guy. So this is the Amana 46200-K. Number might be wrong, I might have switched this up, but 1/8" down cutting end mill. Works great in plywood, MDF, anything fibrous. Now people are going to complain immediately that I need to choke up on the tool more than it appears because, silly me, I need a 1/4" collet. These longer end mills are meant for like full-on routers, so you can only shove this into the spindle so far before it bottoms out. And you never want to actually fully seat this against the taper in the back because the lower portion of the taper is what the collet aligns itself against. The upper drilled portion where the spindle is hollow, it's not really a great reference. So for the Nomad, I like to insert the end mill. Got that a little too tight. As far up as it'll go, and then pull it down about 1 millimeter, and then tighten the end mill. So that way it's floating, it's not butting up against the top of the shaft taper. And that should give you the least amount of run out. So let me clear this junk out. And then let's go to the desktop. All right, so I need to export toolpaths for the 1/8" tools. So back to toolpath. Don't want these small features, we'll disable that. And then let's export SSD cavity and cutout. Dongle _ continued. Jump back into Carbide Motion. Load file, dongle continued. Open, start the job. We should see the initial touch off. It'll prompt me for the tool. I'm just checking the chat real quick. No, the Nomad is an ER11. ER8 wouldn't be able to accommodate 1/4" tooling, but we should be able to go up to 6.5 millimeters or 1/4" on the ER11 collets. Okay, so tool change, insert 102. This is an 1/8" down cut. It's not technically the 102, but they're all basically the same in terms of the cam side. It offsets the tool from the sidewall by 1/16 of an inch. So I'll resume this, and then I will drop the volume, and I will shovel food into my face while this cuts. If this starts moving again, well, let me know, and we'll assess from there. All right, I'm back. This can definitely go faster. Or actually, this is the first step down. So this is going to be easier because I programmed this in as 1/2 inch. So it's cutting what it thinks is the first step down. That's more like it. We can still go faster though. Well, that was unfortunate. Let's do a post-mortem and see what happened. Okay, so weird, cut all the way through. Let's switch back to the desktop. All right, let's try and figure out what happened here. Max depth. Oh. All right, so this is kind of an embarrassing teaching moment. So the last time I made the this guy, um, I tried to cut all the way through the material. There was a little bit of an onion skin left, so I came back here and I set this toolpath to do a full depth of pass cut just to like clean up the onion skin. And so I changed the depth per pass to 9 millimeters, which is almost all the way through this. And I just exported just the cutout toolpath to go around this piece and clean up that onion skin. I saved that. I probably shouldn't have. And so when I exported this last toolpath, it thought it should plunge all the way through the stock and then try and route out the entire piece. Now the work holding would have given, the tool probably would have given, the spindle definitely couldn't handle it. But this gives you an idea of what happens when you crash a pretty friendly desktop machine. It's not the end of the world, nothing terrible happens. It is slightly embarrassing. So we're going to re-export this with a depth per pass of, oh, this is weird, we're in metric. That was a decision, that was your fault last time. Let's go 0.8 millimeters, and we can fiddle with the feed rate as we go. Yeah, I know, I'm pretty impressed that the tape didn't give up, so that's a good sign. That means the work holding should be pretty solid. That means we should be able to push the finishing toolpath pretty fast. So this, let me just double check all the parameters. Depth per pass, less than a millimeter, check. Max depth all the way to the bottom. Cutting on the outside, check. Disable the SSD cavity because we're done there. Just export the cutout toolpath. Save G-code. I'm just going to overwrite this file. And then we'll reconnect to the cutter. There's a current overdraw protection, so when the spindle stalls out, it just resets the controller. I'm actually pretty impressed it made it that far. Okay, so it's reinitializing. It's going to ask me for the tool. Check. And while it's going, I'm just going to load the new toolpath. Start that. Make sure we're back at 100% override. And oops. Okay. This is a minor bug, but I know what's going on. So what's happening is in Carbide Create, which we're about to start a new software dev cycle to iron out bugs like this. But so what Carbide Create's doing is it's seeing the first operation with the 112, and it's like, hey, insert a T6, an M5 T6, or not T6, an M6 T112 command to quote unquote change the tool for the 16th inch end mill. It's seeing the second toolpath saying, oh, this is an 1/8 inch operation, so load the 1/8 inch tool, insert your M6 command there to prompt for a tool change. And it's seeing this, it's saying, hey, this is another 1/8 inch operation, but there was one preceding it, so we don't need to insert the M6. So if I move this up, it should properly insert the tool change command and the spindle enable command, which was missed in this case. We'll get that sorted out for you in the next revision of Carbide Create. Look, we're crashing the CNC, we're finding bugs. This is a great day. So let me double check that the new toolpath has correctly received the, there should be an M6 command. Let me re-export that just in case. So cutout, save G-code, dongle continued. All right. Let's go into Finder, and there should be an M6 command in here and a T. That's weird. Okay, we're going to do some manual G-code editing today too. So before the preposition for plunge, I'm just going to manually turn on the spindle. So M3S10000, M3 being the spindle engagement command. In the clockwise direction, there's also an M4 command if your spindle can rotate backwards, ours cannot. So I'll save that. That should turn on the spindle. And since there's no M6, it's not going to actually probe the tool over here. It's just going to go straight to cutting. I'm okay with that. So load new file, latest version of that. Let's start the job, and hopefully the spindle turns on. And I'll drop the volume, and I'll see you after this tool cut. All right. All right, we're back up to volume. So you might have heard the cuts towards the end in here and here get a little chattery and violent. That's just because downcutting end mills in general don't do a great job of chip evacuation. It's literally just packing sawdust deeper into the cut and making it harder for itself to push through. That's why I was coming in with the vacuum a lot more frequently towards the end. An 1/8" upcut wouldn't do that, but then you also wouldn't have this clean surface on the top. So that's kind of why I wanted to do the 1/8" down cut. So I'm going to pull this off. We did cut completely through everything, which is great. And plenty of tape in there. Yeah, this thing was stuck on pretty good. If I had a little sandpaper, I would totally clean up these edges. But overall, it came out pretty good. I won't shove a USB dongle in there, but confirmed, fits in pretty nicely. Goes in a little more than the other one, so there's a little less slot, so that's fine. Let's make sure the SSD fits. Cool. So everything works great. I'll probably throw this on my desk, and we can finally conclude the dongle drama. So I'm going to switch back to the desktop a bit while I rearrange everything and set up for the Q&A section. So if anyone has any questions about what I just did or questions about CNC stuff in general, let me know. We're going to go back over to this side. And set this back a tiny bit more and pan up. All right, so I'm just going to go through a couple questions I have on my to-do list. First one being, what is the difference between the BitZero and the BitSetter? So, let me get a little slack here. Move that over there. BitZero is our touch probe. So you throw this on stock, and you can figure out where your stock is positioned in your work area. So you throw if you're just finding the Z, you throw it on this edge. So it's riding on top of everything. If you want to find the X and Y or X, Y, and Z, you throw it inside this ledge so that this corner is there, and it'll compensate once it touches off here and here for the diameter of the tool. And so that's how you find where your stock is positioned relative to everything else, more importantly, relative to where you homed off from. So that is what the BitZero does. What the BitSetter does is if you change a tool, it'll compensate for the difference between this point and the new tool if it's longer or shorter. So different tools will stick out different lengths depending on how you insert them. And if you have a multi-part program, like what we just did over on the Nomad, when you load a new tool, you could use your BitZero, find that position again, or use the BitSetter and figure out the difference and have Carbide Motion compensate for that automatically. So ideally, you use the BitZero, you find your X and Y once, and then from then you only use the BitSetter. Now, if your stock looks like this, you could actually live just fine without the BitSetter and just touch off on your stock every single time you load a new tool. Totally valid. The downside is if you're machining something like a topographic carving or like a cutting board where you're putting chamfers on the edges, you're not going to be able to find that same corner on your stock again because this won't sit in the exact same spot. And so once you lose that reference position, the only way you're going to be able to recalibrate or adjust for a new tool length is either you reference something fixed, like the wasteboard, or you use a tool setter. So let me know if there's any question about what I just said there. What firmware is on the machine? So this should be running Gerbil 1.1. I think all of our machines for the past couple of years have shipped with that now. And just doing a little cleanup here and pulling out the surface to control the machine. Hold on, I forgot my pin. I've got 3 different machines here. Each one has a different pin. Nope. Okay, there we go. Where was I? Let's see. First, you should isolate the wood with mineral oil. Depending on what you're cutting, potentially, but I don't know what the context is for that. How to have an up-down compression bit so you get the best of both worlds, clean surface and deep removal. I don't think I have one here. So basically, a compression or up-down end mill has up-cutting flutes at the bottom and down-cutting flutes at the top, so that as you go through material, you're pulling the bottom fibers up and you're pushing the top fibers down. And because on this guy, hold on, let me transition. There's actually a good bit of fuzziness on the bottom edge here. It's hard to see. Let me zoom in. So I think you can see it best in, is this auto-focusing on me? Oh, I think it is. You can see a little bit of fuzziness down here, and that's because the down-cutting end mill was pushing the fibers down. If you had an up-cutting end mill, it would pull the bottom fibers up, but it would also pull the top edge, those fibers up as well. So compression end mill would give you the best of both worlds. It would pull the bottom fibers up and it would push the top fibers down. The only downside is there's a transition point in the tool where it goes from up to down. And if you don't force past that point on your first pass, the top edge is just going to get ripped out. It's not going to have any of the benefits of the down cutting portion of that end mill. So it's, if you're confident in your speeds and feeds, you can use them, but it's a lot less forgiving because you have to plunge at least like 1/8 of an inch before those down cutting flutes kick in. Okay, so to recap, BitZero finds your origin the first time, and should you lose that reference point, like if you machine away that corner, the BitSetter will adjust for the Z height every single time you change a tool, and you don't need to worry about X and Y. You only ever need to find X and Y the first time, and then because after that point, the machine will remember the X and Y coordinate. That part never changes. So the only part, once you start machining, that will change when you change a tool is the Z height. So that's why you have the BitSetter to adjust for that. Let me get you guys a little further back. You're not seeing the whole machine. There we go. Better. Okay, let's keep moving. After you use the BitZero, do you reset all zeros? So let's go through it. Let's find this. So I have this enabled with the BitSetter, so it's going to go touch off there. So why does it need to touch off a tool after initializing? So whenever you first turn on a machine, the X, Y, and Z coordinates are saved. So if I just jog the machine all the way back, before we start the live stream, I set my 0 in the center, about yay high off the wasteboard. So after rehoming, after everything, I can wrap it back to the previous X and Y coordinate, because that never changes, so you don't need to find it again, and wrap it down to a Z height. So this is sort of just an arbitrary reference point that I picked. It's a little above here, about a finger's distance. That'll be our scientific edge. If I turn off the machine, change the end mill, when I turn it back on, it'll touch off on this again. And when I tell it to go back to the XY position and Z plus 6, it'll go, the tip of the end mill will be right here again, despite using a longer tool. That way, when you jog, when you're trying to figure out where you should be, you can trust that the position of the end mill is going to be the same regardless of what tool is in there. And it does that check before you start jogging, because if it didn't know how long this was before you declared this position to be like your reference point, when you do load in a tool and the machine does know how long it is, it doesn't know where this is relative to that imaginary point it started from. So to start off, the machine needs to know where that was, what that offset is. Let's see. Yeah, I know, fork for sushi, not ideal. I also don't have any wasabi or soy sauce. That's because my coworkers are jerks and they hog all of it. So that's why you always touch off when you start. And if you change a tool, don't forget to go back to the interface and hit load new tool. Otherwise, if you load in a new tool and you're 0, or you tip your end mills here and you're jogging around, you're setting a 0 and you jog this up and you say, I want this to be my 0, the CNC is going to think you meant up here, not down here. So every time you change a tool or this distance to your stock changes, hit that load new tool button so it recalibrates that. Okay. Let's see what's next on the agenda. How do I check to make sure BitSetter will work? Do I have M6 in my G-code? Well, we actually just did that check previously for the Nomad. So the way the BitSetter works is that when you have a tool change command in your G-code, it'll look like, oh my goodness, my phone is sitting on my enter key. All right, so at the beginning of G-code, you'll see a command. Hold on, let me just close. I have like 20 copies of this open now. I'll open up a previous version. That's better. So at the beginning of G-code, you'll see a command that says M6. That means change tool, and T112. That just corresponds to the 112 end mill that we have. These numbers will be different for each end mill, but the important part is that you see an M6 command. M6 tells Carbide Motion, hey, pause, prompt the user, touch off on the bit setter. And so the presence of M6 in your G-code is what will trigger that touch off. If you don't see an M6 there, that means your end mill is just, your CNC is just going to go straight to cutting. So if you're using a new post processor, if you've accidentally set the wrong post processor, like I think if you go to in Carbide Create, if you don't have the right post processor set, if you have basic G-code or potentially Gerbil, it says tool changes are implemented with an M0. That means it's going to skip the, there's not going to be an M6 command to trigger the machine to go touch off here. So make sure if you have a bit setter that you're using the Carbide 3D post processor, one of these two. Actually, doesn't matter which one you choose. So yeah, that's how you sort of do a gut check, just to make sure the CNC is not going to run off and start machining before you're ready for it. All right, how do I import a picture from the internet? That's kind of, so a lot of people have the idea that when you start machining, you can just download a JPEG, throw it into Carbide Create, and off it goes. There are no vectors or line data in JPEGs. So what you would want to do, let me see if I have anything here that's useful. if I have any good images. Let's see if I've got Inkscape loaded up. Let's see if we can do a basic vector trace here. So if you want to take any sort of bitmap image and convert it into a vector, you can either trace it out by hand, which is super tedious. This is what it would look like. Let's go new, discard those changes. I'm never going to cut that again. And let's bring in an image as our background. Load image, Dropbox, reference that. That is way too large. Let's go 0.1. Let's go 0.05. That's a little more reasonable. So you can bring in an image and then you can trace over it with, let's say, the curve tool. You can just go around here and start. Let me turn off snapping. Basically, you can just trace whatever shape you want. That is the ultra tedious way to do it. I do not recommend it. But that is the quickest way to pick up a vector from an image. Probably not the way you want to go. If you bring in your bitmap into Inkscape, oops. There's a handy dandy path trace bitmap function that you can use. And there's different sort of detection schemes for the edges. You can check and see what it'll do. So this one, it's a little faint, but that should work. Just hit OK, and let me try and zoom in here. I think it's Control. So it'll sort of pick up some of the edges. It's not great, but there are a lot of different ways you can use Inkscape to try and automatically trace an outline of something. Let's try brightness cutoff. And you can change this threshold to change how much or how little is picked up. So if you do something like that, you have yourself a vector that you can bring into Carbide Create and then just trace this out. So if I go into nodes, you can see that there are individual points here. That's what you're looking for from when you're trying to bring a bitmap image into Carbide Create. Let's see what's next. Router dial speeds. How does the dial correspond to different RPMs? You can figure this out empirically, or you can look this up. I know there's a couple places that have documented this data, including on the forums, I think. But at the top end, this maxes out at around 31,000-ish RPM. At the low end, at 1, it's about 10,000, 11,000, give or take about 10%. So I figured out that, at least on the routers I have, 1 is about 11,000, 2 is about 13, 3 is about 5, and it's in increments of roughly 5,000 all the way up to 6. Gets a little nonlinear towards the top, but just if I want to do 16,000 RPM, it's somewhere between 2 and 3. So if you just keep a log of what your values are, I'll also share these in the comments after the live stream's over. That's how you can figure out what the numbers on the dial correspond to RPM-wise. It's really not a big deal. If you're cutting wood and you're off at like 5,000 RPM, it's still going to work just the same. In aluminum, you have a little less wiggle room, but still like within 3,000 is plenty. So it's like number plus or minus a couple clicks. So you have a really large margin for error. So I wouldn't worry about the RPM and how accurate this is. It's really not going to kill your end mill. And as you saw, I crashed an end mill over on the Nomad. End mill's fine. How do I add a tool to Carbide Create? Let's go back to the desktop. Do we have any other questions in the chat? Because that would be a lot more interesting to answer. Is there going to be an option to change the BitZero thickness from a 6 mil thicker plate? I don't believe that's going to be an option at this point, but let us know. We'll try and put it in the queue for things to do, but we have a lot of things to do. Yes, this bitmap image could be machined directly in Aspire or Carbide Create Pro. You could bring it in as a grayscale image and turn that into a height map. I'm just going to bring this in real quick. It's probably going to take way too long. And have a 3D image there. My horse head is a little cut off. But yeah, that's similar to what you can do in Aspire. Is there going to be an option for an RPM-controlled spindle like the Nomad, only stronger? Maybe not. The problem is you need a PWM signal to be received to control that. So you'd have to go full VFD spindle. And let me see if I can find a reference. On the control board, there is a plug for a VFD spindle, or well, for PWM control. So if you go to the controller and you zoom in, on the right side, there's a pin for pulse width modulation. If you use a laser, you're already familiar with this, but this would be the control signal for spindle speed if you have an external spindle and not a router. Let me zoom out a little so you can get a little context. So that's the pin you're looking for if you want external speed control. Bitmap to 3D machine, there's a lot of different options. Carbide Create Pro is one solution we offer. I think it's still free for 1 year if you go to, let me check the URL first. Launch.carbide3d.com /promo. So if you go here, launch.carbide3d.com /promo, you can still register for a free 1-year license of Carbide Create Pro, or you could shell out money for something like Meshcam, or I think vCarve or Aspire would do this as well. Those are the most common options for taking a bitmap to a 3D file. I don't know about Super PID. I haven't actually used that personally. Someone else can probably chime in though. All right, going through a couple more questions. All right, we're going to add a tool in Carbide Create. So you can manage your tool library in Carbide Create by going to Edit, Show Tool Database. And then if I turn off all my filters, you can see I've got a bunch of different libraries for the Nomad for different materials, for the Shapeoko for different materials. If you want to add your own tool, you need your own tool library. So the default ones are all locked by the lock icon. You can't unlock it, but you can duplicate it and make a new version of it. And your own duplicated library is where you can add the tools. So I'm going to duplicate Shapeoko's softwood. It's still going to prompt me for which one. It should default to that. We can fix that. So I'm going to build off of the Shapeoko softwood library. Library name. And then once you have your own library, you can go into the dropdown, pick different categories, end mills, ball mills, whatever. You can, I think, right-click on your library, go to New Tool, New End Mill, New Ball Mill, V-Mill, Engraver, whatever you want. I want to say, let's drop in a new end mill. As long as the tool numbers are different, when you have a tool change, it will trigger the correct M6 command. So if you're trying to use like an 1/8 inch end mill, like the 102, don't call your own tool a 102, because if you follow up on the 102 end mill, it's not going to do the M6 command. The CNC is going to think, oh, hey, this is another number 102 end mill. I don't need to do anything. So make sure all your tool numbers are unique. So I'll just set that to like 7,000 or 700. It's got to be 3 digits. Tool diameter, whatever you want it to be. You can set up some basic speeds and feeds in here. And hit OK. If this were a ball and mill or a engraving or a V-bit, you'd have an included angle that you could adjust. But for a straight end mill, we assume straight walls. So really all you need to change is the diameter. So hit OK, and basically you have a new end mill in there. So tool number 700, 1/8 inch. It's in your library. You can choose it for all of your machining needs. Hello, Craig, and glad you could join us in the Carbide 3D family. Let's see. Another software is ArtCam, which can be rented. It's called Carco. There are many options out there. Find whatever suits you. Do a free trial if you can. It's always best to find the best tool for the job. Some softwares work best in 2D, some softwares work best in 3D. It really depends on the kinds of things you're going to make. Let's see. Can you do aluminum on the Nomad? Yes, you can. So let's go back into our Nomad library for aluminum. If you're not sure where to start, you can start with some of the recipes in Carbide Create. So for an 1/8 inch end mill, we say about 10 inches per minute, about 0.01 inch depth of cut. This is all calibrated for 6061 aluminum. There are different grades, alloys of aluminum. They all machine differently. Some are worse, which means you're going to have to take an even lighter cut. So instead of a 0.01 inch depth of cut, maybe a 0.007 or something. You sort of have to play around with it, but these should all be pretty safe to use. They're all relatively conservative. So feel free to try out some of these settings, and you can go more aggressively, less aggressively, depending on how you see fit, and go from there. Let's see. I think the last question I have is, can you do mild steel on the Nomad? Technically, yes. So the thing about machining is you want your tool to, let me focus this. For every revolution of the cutter, you want the cutting flutes to bite into the material a certain amount. So if you go too slow, if you're not able to feed fast enough, you're basically just going to rub the end mill, create dust, create friction, dull the end mill. It's not good. So the sort of the criteria for is a material practically machinable on a CNC is, can you feed the tool fast enough so that every revolution of the cutter, the end mill is taking a reasonable sized bite out of the material. In steel, you can actually get that reasonable chip load or bite of the end mill into the material, but it comes at the expense of depth of cut, because the deeper you cut, the more material you're excavating with every revolution of the cutter. For steel, that limit that the Nomad can handle is extremely low. That being said, we do have a project, the Carbide Camp Knife, where I machined the bevels for this blade in Carbide on the Nomad. This was using Fusion with adaptive cuts on here. I don't think you could see you can see some chatter marks in there. That's because I had inefficient tool pathing, as the cutter was basically coming in to a sharp corner and making a sharp 90-degree left turn. That's what caused that chatter there. But this is just a proof of concept, slow and tedious, but tool steel machining on the Nomad. All right, I think that wraps it up for everything I have on my list of things to talk about. Where can I buy belts separately? Do I want to buy a maintenance kit for one belt? Yeah, shoot us an email at support. We'll try and do whatever it takes to get you up and running if you have a belt break. If you want to be proactive about this, the maintenance kit does get you everything you need to replace the wheels and the belts all in one shot, and you can have it before something goes wrong and get up and running sooner. I'll stick around for a couple more minutes in the chat if you have any more questions. But in the meantime, I have 2 more pieces of sushi that have my name on it. And I think that'll wrap up episode 15. So thank you all for joining us. We'll be back in 2 weeks with probably another project. I'm thinking I need a monitor stand, so let me show you what I'm working with here. Super janky. So because I just today got 2 machines, Shapeoko and Nomad in here, I don't have a lot of room. But my monitor stand right now is just a pack of aluminum, 3/8 inch sheet. It's like 20 pounds, not the best monitor stand. So I've got a lot of scrap plywood. Maybe we can make something next time. No promises, we'll see, but that's what I'm thinking for another live stream project. So with that said, thank you all for joining us, and we'll be back in 2 weeks. And have a good weekend, everyone.